So visualization, we just had a great panel about the complexities of it all, but the thing that I took away most is that, before we start off trying to analyze data, we really need to understand why, what we're doing it for. And then how are we going to present that, connecting the information to the human being. So this panel is going to really address, now what do we do with that data? We're going to discuss what visualization is all about, good, better, best, no size fits all, I'm sure, and how these organizations are using visualization tools to their best advantage. So we'll follow the same format again, follow each person and have a little dialogue amongst themselves, and then we'll open it up to the audience and give you plenty of time to have questions to pose to them. So let's do some intros first. So we've changed the order up a little bit because Unmil likes to do handstands and flips and everything else while he's talking. So Unmil Karadkar is an assistant professor here at the School of Information. He situates his work at the intersection of digital libraries, human-computer interaction, and visualization. Unmil studies data practices of researchers with a goal of designing and evaluating software to meet their information needs. He holds a PhD and an MS in computer science from Texas A&M University.
Every panel has to have one from.
Has to have one Aggie. Maroon doesn't work here, but that's all right. Then let's see, we've got Cynthia next. Cynthia joined the product management team at Tasktop Technologies in 2013 after earning her master's degree in information science from our school. At Tasktop, Cynthia is immersed in all functions of end-to-end product management. She's come to recognize how basic data visualization can actually facilitate better decision-making and to communicate the complex technical capabilities of a product in a way that's consumable for her customers. Fuyu Li received his PhD in Atmospheric and Oceanic Sciences from Princeton University in 2010. Before joining Chevron's energy technology company as an earth scientist in 2013, he did research in climate and earth system modeling. His work at Chevron focuses on upstream technology development. So we're really pleased to have someone from the energy sector here in Texas. And lastly, Beth Hallmark joined the Texas Comptroller's Office in April 2007. She serves as Deputy Chief of Communications, Public Outreach, and Open Government. She works with the award-winning web, editorial, data, and graphics teams to produce a wide range of print and electronic materials to assist us, citizens, doing business with the Comptroller's Office. In her position, Beth has helped lead the agency's efforts in driving and implementing new approaches to government transparency and public interaction with government information and data, which there's plenty of. She holds a master's degree in information studies from, guess where? Here, University of Texas at Austin. So again, thank you very much, panelists, for volunteering to help us today. So, Unmil, okay, just as Byron did, can you please help set the stage for visualization? What do you mean by it? What's it all about? You're on for at least 10 minutes.
At least 10 minutes, and I think someone's going to shoot me down if I go for more. So one of the things that struck me about the panelists before was how polite they were and how nice they were and all were sitting down at their table. And I was like, there's no way I'm going to be able to do that. So I moved myself down to this end, and I can now move around and chat. So I'm going to borrow a lot from the panelists before me, and thank you all for setting it up very, very nicely for us. So if you like this stuff, right, you are the geeks that Abba mentioned. And really dealing with data is extremely difficult. If no matter what format you choose, no matter what framework you choose, dealing with raw data can be very, very daunting. So we try to put some kind of a visual transformation on it and go, okay, well, we'll try to present it as a table. It's the exact same data now being presented as a table. It becomes slightly more tractable. You can do slightly better things like you can highlight cells and you can start seeing relationships in 2 dimensions rather than 1 dimension, which you did in the list before, right? And it becomes slightly better, but you still don't have a sense for what it is. And then you can take it another step up. And this is still very familiar. It's line graphs. We know how to deal with these. And now suddenly you can start seeing the peaks and the valleys and the correlations. You have two lines going up there in the morning. And then you have a lot of different kinds of lines going up in the evening. And you can see all of this without really understanding what the data represents. You don't know what those numbers mean. You don't know what the peaks and valleys mean. But you can start seeing the correlations between various data points. And what we've effectively done, going between that first slide and going between the third slide, is we are now using more and more of our brain's visual input bandwidth to make sense of that data. Right? The question of domain is still far, far away. So to put this in a framework that we are all very familiar with, we know what this is. I don't need to say anything about it. And visualization really takes us from that unhappy state to the happy state. And you can imagine that as you get more and more fancy with this, you get better and better with the kinds of responses you can provide to the data that you're getting. So you have data and you have people. And the whole idea is to get that data from a database somewhere into a person's head, hopefully with the goal of doing something with it. And as Abha mentioned again, it's incredibly hard to do this. So what we do instead is we try to use visual surrogates of that data. And we create visualizations, and we have the brain understand the visualizations. We understand space, we understand color, we understand similarity, we understand differences. And we go back and forth between this. And eventually, people understand what that data is. And then we transfer it back to the abstract. And hopefully, there is insight that comes into play at some point that you can act on. Right. So putting data at the center of this life cycle of activity, this is where think of Oprah going, right, there's a car for you, there's a car for you, there's a car. Everybody gets a car. It's a similar thing. Everybody gets a visualization. We talked about there being different needs and goals and demographics and use cases. And I think every single place in this business pipeline can benefit from a visualization. Okay? And then what happens is usually is we think of visualization as a single entity, and it's hardly ever so. So imagine you have data and data comes in. You want to make sure that the data is valid. And then we touched on some of these things earlier. So what you do is you do some exploratory visualization. You can easily see the outliers. You can easily see where the highest density of data is. And that falls under exploratory visualization. And you can see the data wranglers, the people who were talking about the earlier panel, benefiting from some of these processes through a visual metaphor. Right? Where is your data good? Where is it bad? How diverse is it? How homogeneous it is? All of these things you can do very easily with what's called exploratory visualization. On the other side, once you are fairly certain that your data is what you need it to be, you can start thinking about analytical visualization. What is it that you want to get out of this data? What are the questions you're asking and what are the answers you need? And now you're starting to work with analysts. Now you're starting to work with people who are going to create some tangible output for the company. At some point, once you are satisfied with the analytical visualization part, you can start merging the data with your business goals to create dashboards that can provide information to management, but also to a broader, I'm generalizing here, clearly. Right? It's not that dashboards are just for management. Clearly, they serve a broader audience, or they can. And then finally, even at an even later stage, you can build in some additional design, some additional curation into the data process to create infographics and push things out to the broader public. And this, in my view, is a key to understanding visualization, because very, very often the terms visualization, dashboard, infographics get used interchangeably And that's a cause of a great deal of confusion for people who are either trying to learn what the field is or trying to use some of these techniques for getting their message out to the right demographic. So doing the right kind of analysis, doing the right kind of interpretation is easier if you're using the right terminology to go with it. So just to clarify here, infographics tend to be highly, highly curated, whereas visualization is usually algorithm generated. You're interacting directly with the data, and there is a computer process that's generating the visual. It supports exploration analysis, whereas infographics usually have a predetermined conclusion that you're trying to convey to some audience. Infographics tend to be much more aesthetically pleasing, that they're much prettier to look at, and people just go, oh, isn't that pretty? That need not be the case with visualizations. It can be, but it does not have to be. So you have a much more balanced view in terms of functionality and the visible output. And we'll look at some examples of this. And in terms of interaction with data, infographics hardly ever have any back and forth exchange with the underlying data. It's almost always a one-sided interaction where the data informs the graphic, but the graphic does not inform the data back. Whereas a visualization is usually data dynamic, where learning something from the visualization, you can go back and either modify the data in exploratory visualization, or you can learn something new from it and go back and change the view to either include or exclude certain data from your next round of visualization. Let's go ahead and take a look at some of the visualizations. And then really the idea here is to just set it up so that we are looking at more than just the line graph I showed you earlier. So this is part of the fun of being on this panel, where we get to play with pretty stuff. So you're looking at the US trade deficit between 2001 and 2013. And what you see is the largest countries where the US has exported and the largest countries from which US has exported as a, I think it's a dollar amount is what it comes down to eventually. Right? So again, business doesn't have to be boring. You can bring in interesting, artistic even, processes into the analysis.
So that was an infographic?
No, that is a live visualization. And in fact, for every one of these, I've put in where it is. These are all interactive visualizations that I'm showing here. If you like, I'll be happy to share the slides eventually. Because surely, who can't just type that in while I'm speaking? And by the way, most of these are done in D3, which is a framework, JavaScript framework for web-based visualizations. And also what you're going to find is many of these are focused on government humanities data, because for some strange reason, businesses just don't want to put their real data out there. So that's a view of the federal budget, how the numbers break down. And you can see that I've hovered over welfare there, and you can see how the numbers break out. I'm not going to go into the details. Here is one that I particularly like. In most cases, you think of a single data point being represented at a single location on your canvas when you start visualizing it. The parallel coordinate system instead shows multiple axes all next to each other. And single data points are represented by lines that connect various attributes of a single data point. Right? So now you have exploded even what's a data point, and you are showing it as a line and connected features. So this brings out some very different aspects of data that your typical visualization cannot, or a typical line graph view, say, cannot. Right? And what you're looking at here is what are the various contents of yogurt, plain skim milk, 13 grams per protein per 8 ounce. Here is one that shows the interactions between various characters in Les Miserables. For some reason, Les Miserables is the most popular thing to visualize when it comes to novels and plays. And what this is showing is you have the same set of characters along the x and y axes. And you're looking at interactions between characters. So all the things in green is one cluster. And you're seeing that here is one character interacting with all these other characters. Okay? And then you see a different cluster, and you see a different cluster. So essentially what you're seeing is there are groups of characters that interact with each other, but there is very little interaction across these groups. And then you see an outlier here. Valjean ends up interacting with a whole bunch of people. Right? So this kind of gives you a very, very new way to look at Les Miserables and look at the interactions between people. Here's another way to look at the interactions between people. So one was a grid view. Now here is an arc view. It's the exact same data. I don't know what that is. And here is yet another view, where now what you're seeing is that you're also seeing the moods of people. And the blue is a happy mood, red is a sad mood. And the height of the bar shows the number of mentions in each chapter, 1 to 20 or more. Right? So here is a very, very new way to read novels, to visualize plays, to think about plays. And this can enhance or improve scholarship in certain areas. We have some people here from Boston today, I'm told. So here's a visualization of the Boston Metro.
Don't even go there.
So what you're seeing here is each train departing from one end, following it to the other. And what I've done here is I've highlighted one particular point on one line, and that's this. And you can see at any given time how many trains are running on each line. I don't know what the practical application of this might be, honestly. But it's pretty, right? It tells you something. And then you can see that the density of trains here is slightly lower, and then as you get to the peak hour, you can see a lot more trains running at one time. For the sports fans, the probability of Texas winning the March Madness is 0.1%. I think the highest one was like Kentucky or something, which was at 34%, I think. But again, a very, very new way to look at March Madness brackets. And if you want to play in this space, what happens is you end up relying on a bunch of interdisciplinary people. Right? What I just showed you is nearly impossible to do with just a programmer, or with just a psychologist, or with just a data scientist. What you need is people, teams of people, who understand the overall goals, and who are willing to work with people who don't necessarily speak their language. And this can be a challenge for small organizations. So if you're a small startup that's trying to do visualizations, the inclination is to say, we have a visualization guy. Right? We have an IT guy, we have a visualization guy. It doesn't quite work that way. So that's about it. Thank you.
So we've got a few minutes for the panelists to react or respond to what Unmil said. Beth, you're shaking your head.
Yes. So I love the comment that you made about thinking about what's the question that you're trying to answer, because that is really where it begins. And if you don't have a clear path on what the story you're trying to tell, any road will get you there. So that's one thing I think that sort of ties together the panel before us and the panel now. It always begins with the data, always has to. The quality of the data that you have, but what are you going to do with it? And that is where visualization comes in. And that comes down to the use case. What are we going to do with this? And then it becomes very, very powerful. So I just wanted to stress that point, because I think it's sort of these buzzwords, big data and data visualization, and what does it mean? And it really is about answering questions.
Yeah, I agree. And I mean, so the thing that brings it all together in my mind is the domain expert. Right? You can have a programmer who can write some code, and you can have a data scientist who can look at some data, and you can have a psychologist who can say, well, what is the best way to get this to an individual? But unless you have someone who can make sense of it and say, well, really, yes, you can do all of that, but it just doesn't make sense for this audience. So that I think is the key in my mind, where if you're working with financial data, or we talked about SOB, right? What does it mean? And then you really need the domain expert to bring it all together.
Actually, from Beth's comments on your presentation, I want to pick on one sentence you mentioned. You said the fancier the visualization is, I mean, the better. Actually, I don't really agree with that. So I think the main purpose for the visualization is to answer a question, answer a specific question. So if you can make the visualization like simple enough for all the people or all the general audience understand this question, I think that's the best visualization. So for your whole presentation, for all this kind of fancy visualizations, the picture I like the most is the smiley face.
Which one was it for you?
The smiley face.
Oh, the smiley
The
face.
smiley face.
And I promise me for my presentation, I should have like more fancy picture.
Well, you raised a great point, though, is to really make it consumable at a glance. I mean, we live in a world of data. We live in a world of information overwhelm, as Dean Dillon pointed out. And so just to make it really clear the points you're trying to make in as simple a way as possible. When I talk about what we do at the comptroller's office, there's a lot of complexity involved in the information that we have. But how do we boil it down to its bare essentials? And we're just, as human beings, our brains, we visually understand things much quicker than we do anything else. So it's leveraging the power of our brain to visualize information effectively.
Yeah, I guess I'll add to that. Even from my presentation, you'll see that, well, first of all, I'm going to explain that we don't even have one data visualization person in our small company, so we are kind of set back even more, much less having a whole team. But we kind of do what we can with the resources that we have, and we have a lot of struggles that I'll go through. But we do produce some basic visualizations, and even though they might seem pretty minimal, we've been able to derive insight that's actionable from it.
Yep.
So.
I have a question for you. Actually, it's coming from our photographer. We were chatting out at the food station, and he said, I'm colorblind. What happens to me in all of this? And, the samples that you showed definitely were color oriented, right, in trying to convey what the message is.
Absolutely.
So, any thoughts about that?
Absolutely, and this is a question that we all need to be very, very aware of, right? When we start designing things, especially if you work for a governmental organization, you are bound by something called Section 508, which is accessibility for people with disabilities. And that's exactly why you need a designer on your team. I don't know if I have a designer on that, right? There's visual design. And the questions like that absolutely get considered by someone who knows something about design.
Yeah, it's a great point to make, actually. And we always, every time we're working on anything that we're trying to convey graphically, we think about accessibility for everyone who will look at it. And is color the only way we're conveying meaning? That can't be the only way. I mean, we really need to be cognizant of all of our audiences and how they'll consume the information. But it is an ongoing challenge, and it's something you have to be vigilant about all the time.
Yeah, that reminds me about my PhD defense. When I showed my figures to my supervisor suggested me to take some of the green line and the red line out of one figure, so you don't combine the red line and the green line in one figure. Yeah.
Okay, I think it's time to move on to Fuyu.
Okay, I'll
Could
stand
you
up.
please, yes, you may stand up. Our question for you, our prep for you is, could you please describe how you use visualization at Chevron to bring together very complicated data in a way, and from a variety of systems, in a way that humans can make more thoughtful and informed decisions? So the clicker is there.
Let's see here. All right, before I start, I really want to thank Unmil to introduce all this kind of general information to the audience so that I can directly jump into some technical examples. Visualization actually, as mentioned earlier, I work in Chevron's energy technology company. I basically work on the technology side. So basically, there's this presentation. I'm going to talk from the on the technology side, and the view is basically from a user of a customer of the visualization tools. The digital visualization actually is very widely used in the oil industry, pretty much in every aspect. or function in the oil exploration life cycle. So as the oil exploration really get into the more complicated area, more deeper or structurally complicated areas, we need the advanced tools to do the analysis and provide the information to the decision makers. So the digitalization is one of the most fundamental and necessary one, like among all these kind of cutting edge techniques. And so I would say without adequate visualization component inside, no software or any tools will be widely used in our industry. And so here I will show 5 examples of the digital visualization in the oil exploration different cycle at different stages. And the spoiler is there will be technical terms, but please pay attention to the beautiful pictures. You don't really need to understand the technical terms to really understand the importance of data visualization in the oil industry. So the first example is called, the function is called the basin modeling. So in oilcom, the basin modeling essentially is to use the numerical algorithms and some geology data to study and analyze some of the dynamics and formation of certain sedimentary basins. The goal is to trying to find if the past conditions are suitable for the hydrocarbon to be generated and preserved in that certain basin. So it involves many complicated processes such as deposition, faulting, some multi-phase turbidity flow, kinetics, or these kind of things. Since it involves so many different physical processes, so visualization of this modeling is very challenging, but very rewarding as well. So this figure basically shows one example of the basin modeling. On the left is essentially it shows the flow, the height of the flow during one flow event. On the right is basically the deposition thickness of shale. So the circles here basically is emphasize one region with very fine particles in this topography high region. So this essentially could be a good potential hydrocarbon reservoir. So this is for the basin modeling. And the second function I'm going to talk about this is called seismic interpretation. So the basin modeling and the seismic interpretation are the pre-production stage. So the seismic interpretation essentially is trying to extract the subsurface features so that the geophysicists, geoscientists can locate where the hydrocarbon is inside the reservoir. And they can just provide the information to the production, like the reservoir engineers or some different decision makers to decide like where they want to drill that well. Data visualization, of course, is essentially the cornerstone of seismic interpretation. So the geoscientists basically use the visualization to improve their quality of the interpretation and also to reduce the turnaround time for their interpretation. So this is particularly important since basically the geoscientists are dealing with increasingly large data set. And this one is an example of the seismic interpretation. It's one of the advanced integrated unified interpretation. So the upper panel actually shows one of the the amplitude. Is the geobodies of the salt in the deep sea side, in the deep sea field. This is the first stage of this interpretation. And after 7 steps or so you get the lower figure, so which the red color basically shows is a surface. So you have terabytes of the input data, and at the end, you just got that maybe kilobyte of the data at that surface. So you integrate all the seismic data, well data, some interpretation data combined just to get that right color in the lower panel. And the third one is reservoir simulation. This is another important discipline in the oil exploration. I think this picture is maybe better, right? Yeah, reservoir simulation is you use the numerical models trying to simulate the flow within a reservoir. The fluid flow means water, gas, and oil. So the reservoir engineers use the visualization to really monitor like the changes of the flow within the reservoir, the distribution, the changes of the flow within the reservoir. So it helps the reservoir engineer to optimize the well design and enhance the oil recovery within this reservoir. And this figure basically essentially show one, this is actually a simple figure. It shows the reservoir's simulation visualization. So the line is basically the location of the wells, and the color basically means the porosity in this reservoir. It's the space between the rocks and the grains inside the reservoir. So one particular challenging issue for this reservoir simulation is people are trying to do the real-time monitoring of the reservoir. So you have the real like 3D monitoring the view of the changes of the reservoir within the reservoir. So it's caused significant challenges for the software and the hardware associated with the visualization, actually. And the third one is called Metocean. This is quite different from the previous three. So especially during at the offshore or coastal platforms of the fields, so the infrastructure often like threatened by certain meteorological and oceanic conditions, such as hurricane. So this function actually is an engineering function which study this kind of oceanic and meteorological hazard, which will ensure the operation are within done within the safety limit. So the reservoir engineers, the Metocean engineers needs to analyze a lot of data each day to monitor all this kind of hazards. This one shows one example of the visualization. It's actually showing one hurricane heading to the US coast. There is the location, strength, and the vertical structure of the wind speed field of this hurricane. So when you have when you are able to visualize the details of this hazard of this kind of meteorological phenomenon at the real time, so you can provide to the operation teams like when they need to stop working and when they don't really need to stop working. This will significantly reduce the loss due to the downtime. So this figure is not really as pretty as the previous one. I keep this one here is because the function is called the 4D seismic surveillance. This one is done like post the production. I keep this one is trying to emphasize the analytics behind the data visualization. So, so from the figure on the left to the right, so you can see within this highlighted circles, you can see there is some signal greatly enhanced in the right-hand figure. So this is done after you apply certain analytic techniques on top of this left-hand figure, and then you can really get some interesting signal you cannot really see in the original figure, and actually in the signal you see in this circle on the right-hand figure actually are the very important changes within the reservoir due to the oil production. This is very useful for the final production, and that's it.
So, Fuyu, what did people do before all of this? and I know Susan Cisco, Dr. Cisco worked for the Railroad Commission with all the oil and gas records, but those were mostly analog, right? And so how did people figure out what to do before all of this?
So I talk about file functions. It doesn't really mean I fully understand all this kind of file functions.
Okay. There's a disclaimer.
Okay, for each function, there are specific teams or even an organization, like reservoir simulation, there's an organization who's really working on the whole thing to really get the data in and do the analysis and really get some figures or some visuals for the decision makers to make decision. It's really a big team effort.
So panelists, do you have any
I
questions
guess
you want to
so.
ask?
I was wondering not only, who is responsible for putting together these visualizations, but it seems like, for each of them, there are dedicated teams
Yeah.
that are focused on it, which I think is great. But I'm also wondering what kind of tools they use to generate this. Are they kind of internal applications that Chevron built, or are they software tools generally available?
There are internal applications. Yeah, I developed one of the plugin actually for one of the function I mentioned.
Wow.
But the most of the time we use the vendor softwares, like a lot of vendor softwares. We pay a lot of money for that.
And I was curious about how your visualizations evolve given new technology and new innovations just in the field of energy.
Yes, it has been like involved really fast. I mean, honestly, I cannot really imagine like how the people 30 years ago, how the people really do this kind of work.
Mhm.
Like I mean, without this kind of advanced computer techniques, I cannot really imagine. Yeah, but right now, like, so you have to keep pace with the development with specific techniques, and there's a software and hardware enhancement all the time. So we do this kind of like, we got the release from the vendor, big vendor software companies, every quarter, every month. So we have to take in the new techniques and then the new need actually from the daily work, and we have to assimilate the new techniques from the industry, from the vendors of software companies.
So one of the things that's really easy to do with visualizations is get caught up in the visual and believe it to be true, right?
We never believe it's true.
Right. So that's the question: is how do you build in that notion of that there are certain ground truths that you know to be true, but then there is a layer of interpretation that you know to question.
Mm-hmm.
How do you communicate that, or how do you learn that in a visualization like this?
So most fundamental, this I would say principle behind all this kind of function is physics processes. It's physics based, and when you get beyond the physical based, when you do the interpretation, for example, so that relies on experience. So for some very experienced geoscientists, they can from that single figure, they can tell a lot of more information than me. Yeah. But the basic is still the physical principles.
So one question I have is, in industry, we pay a lot of attention to return on investment, right? And we've started talking about return on information as feeding into the return on investment. Has Chevron built out that sort of financial model that shows that with using all this visualization that you've actually lessened cycles and improved production and safety issues with hurricanes? I mean, is that part of the process as well?
There are certainly this kind of metrics. Yeah. Otherwise,
You wouldn't be able to fund it,
yeah,
right?
Yeah.
Exactly.
There's no money for you.
That evolution would end, right? The project would stop.
Yeah.
Any other questions from the panel?
I love the idea of return on information. I hadn't heard that term before, but I'm going to use it.
Oh,
I like
well,
that
join
lot.
a webinar on Thursday. I'll give you the information and you'll
Great.
learn more about it. Thank you, Fuyu.
Thank you.
Cynthia, you are next, please. And what you're going to do, you've shared the fact that you're a small business. You've had some challenges here. You don't have the staff, but you have some great insights about visualization. So looking forward to hearing it.
Right, so I'm going to talk to you guys about data visualization in product management. And unlike Fuyu's company, that's a large oil company in which data visualization is very much ingrained in what the organization does, we're totally at the opposite end of the spectrum. I work on a product team of about 4 people at a small but growing software startup of 80 people. And so I kind of wanted to walk you guys through our journey over the last 1 or 2 years in terms of realizing just how useful data visualization can be in product management, but also highlighting some of the struggles that we've faced because of a lot of constraints we have around resources, such that if anyone else out there is on a team or in a company who's wanting to do more and more with data visualization, maybe you guys can learn a bit from the things that we overlooked and avoid some of those pitfalls. I have one primary example to talk about, though of course there are many areas in which data visualization can be useful in a product management team. But release planning is a primary function of any product team. And this is basically the act of, for an upcoming release, defining the set of features that are going to be built out in the product and scoping those features down such that the business knows what to expect out of the product in a few months' time. And a good release plan does two things, in my opinion. The first is that it strategically gets a company to where it wants to be in about a year. Another planning document that software companies and product management teams do is called a roadmap, and that, again, sets goals out for where the company wants to be in 3 or 4 releases' time. And the idea is that with each release plan, you're kind of incrementally getting closer and closer to those longer-term goals. So a good release plan needs to make sure that you're on track with the longer-term objectives. At the same time, it needs to do so in a way that's realistic for a given time frame. And in order to do that, you really need to have a good understanding of engineering capacity in terms of how much work the engineers can realistically get done in 3 or 4 months' time, or however long a release cycle is, but also in terms of where they're spending their effort. Because as much as my team would love it if the developers, spent all of their time developing new features, the reality is that they have an existing code base that they need to maintain. We have existing features, existing customers. Inevitably, they have things like defects and technical debt that occupy some of their time. So we need to strike the right balance in terms of how much they're spending on maintenance versus on new business effort. And so that's really important for us to understand. And if you kind of don't analyze these things, it can be really bad, because then the engineers, if they don't think that you're really analyzing and trying to understand what's possible, they're not going to have buy-in for the plan. They're going to think that they're getting overloaded. Whereas if they can tell that we've been thoughtful and we've analyzed and tried to come up with a more realistic estimate, they'll kind of get on board with what we're doing, and the entire release process will be a lot easier. And of course, you don't want your release plan to be overly optimistic, because then you're kind of over-promising management. And at the end of a release cycle, when you haven't delivered what you said you were going to, there's a lot of ramifications and a lot of explanation that has to happen. So release planning and getting it as accurate as possible is incredibly important. So in this area, data visualization can be incredibly useful, and we've kind of quickly realized that over the last year. Because instead of trying to just export a lot of tables from the developer's tool that they use and looking at static numbers with user story counts and defect counts and whatnot, seeing that information in a visual way is a much easier way to kind of get a quick idea of what's going on, which is also important. So I will show you one visual, or a kind of little dashboard that we have. And as you guys can see, this might not seem like the most robust kind of thing, but if I look at this very quickly, I can get an idea of how many story points the engineers can complete, how much they complete on average, and how much of that is new business value versus maintenance and whatnot. And even though this might seem relatively simplistic, I'm going to kind of explain why even getting to this point and maintaining this kind of thing is really difficult. And I'm actually going to click away from the visualization now. So here's some kind of concerns or things that we've dealt with in getting even to this point. This first point gets a lot to the data wrangling part that we talked about in the first half of this panel. In order to get that visual, you need to make sure that the right data points are being recorded. So first of all, the person needs to kind of have an understanding of what the goal is for the visualization, getting back to what is your use case. Our use case is to be able to understand all of those factors I was talking about. And then you need to be able to go back and make sure that the engineers are recording the metadata that's necessary to generate that raw data to then generate the visualizations. So we found that the person who's doing the data visualization really needs to be familiar with the engineering teams and with how they operate, and they need to have context. So if I wanted some kind of data visualization to show capacity and effort, I couldn't have just brought in someone who was great at making charts or using the D3 library. They really need to be someone who's embedded with the teams and who has that context so they can identify the gaps and whatnot. Another really important thing with, I guess, this and any visualization is just to make sure that the data is being recorded consistently. Because we found very quickly when we were trying to get this process going that different teams were recording different metadata, they were counting things, categorizing things differently. If you have one team that's calculating their velocity and they're excluding their artifacts that are tasks, but another team is including it, the numbers quickly become skewed, and it is really difficult for our team to get a snapshot of what activity looks like across your development organization. So again, the person needs to have context, and they need to be able to have enough interaction with the team such that they can actually establish that process. And And of course, whenever you're setting up any process that's new and unfamiliar, you need to be really diligent about it and check in with the teams to make sure that they're doing it. So the person, again, can't just be some detached individual who's good at visualization. They really have to work with the teams on an ongoing basis to make sure that the right information is being recorded. And finally, in order for this kind of visualization and any to be useful, the data that's driving those visualizations needs to be up to date. So very quickly, those kinds of visuals get out of date. And that's not going to yield us the insights that we need that are actually actionable. And this is kind of where we've struggled because some people would argue that the person or the people who are doing this kind of generation in examining the engineering effort should be the actual developers because they're familiar with how they operate and whatnot. But if you are at a small organization where you have a limited number of developers, it's going to be very hard to convince management to devote their time to internal projects like this. They want them focused on building the customer-facing features. So because our team works so closely with them, we were able to identify the gaps and establish a process. However, we don't have the technical skills that are needed to kind of make the automation and visualization of this data on an ongoing basis very easy. We have, again, seen that kind of visualization yields insight. So we've committed one of the people on my team to doing it. But again, she doesn't have the scripting, et cetera, kind of technical skills that you need. So every 2 weeks, she goes in, she queries the database, she pulls out the data. But it remains a very manual process. And if we had kind of a different skill set, that process might be made easier. And so absent of that, you're really dependent on both the time and tool dependency. So this is not something that, my colleague, this is not her dedicated job. This is something that she's doing on top of her other, product management responsibilities, which are numerous. So this is kind of just like, not necessarily an afterthought, but it's something that's on the side. She's not dedicated full-time to doing it. And because of that, there's also a dependency on the tools we're using. She doesn't have time to go off and learn a cool new tool or to get familiar with the D3 library or something because she's just trying to get this information out whenever we need it. So without a dedicated visualization expert, you are working with those constraints. Oh, and the thing is, I'll highlight too, this kind of is becoming more important, right? Because our company, again, is growing. So as the number of teams is growing and as the number of the responsibilities increases, like the need for this data rises immensely. But our process currently for doing so becomes all the more unsustainable. So some high-level takeaways. Visualization is key to product management functions. Release planning is only one of the areas in which we've identified a need for visualization and how it can help us. It would also be incredibly useful in things like road mapping, which is that longer-term strategic planning that we do. Because in our industry, we have a lot of stakeholders who are driving the things that are getting prioritized, and those priorities change quickly. So if we had a way to communicate how those priorities are changing over time and why, that would be awesome, but we haven't found a tool to do that yet. And this is also important in field enablement. So we're not only responsible for planning a release, but at the end of a given release, we need to be able to communicate to our field people, our sales guys, our solutions guys, the ones who are actually selling to customers and getting them deployed, what the technical capabilities of the product are. And because our product is very technical, it's integration software, it's really hard to communicate that in endless tables. So this would be another area where it could be useful. And in fact, we did try to bring in an intern to do the D3 library thing, but that didn't work for another reason that I'll highlight. Familiarization with data and context is critical. As I said, the person can't just be entirely removed from the company and the operating of your team. They need to be intimately involved. Technical skill set is important, especially for ongoing maintenance. I pointed out reliance on capabilities of the tools you have. This one I didn't quite get to touch on explicitly, but in another example, we found that iteration is necessary to produce the right visualization. While we generally have an idea for the kind of output we want, you're never going to get it right on the first time. We brought on a summer intern to try to help us with some of the field enablement stuff, and we went back and forth, reacting to what she was producing and saying, well, this looks, mostly right, but maybe this should be displayed in this different way. And so you need a dedicated resource to be able to do that kind of iterating. Creativity is also key. I feel like because the people in my department, we have a lot of skills and we contribute in a lot of other ways, but because we lack that kind of creative element, we don't have the end vision for what would truly be like an effective visual. Like we know the things that we're interested in, but we don't have the time or that kind of way of thinking to be able to develop the full vision. So we need a mix of creativity and technicality, which is a little weird. The maintenance aspect shouldn't be overlooked. Again, for those stats that are monitoring the team's performance, that's going in and doing it every 2 weeks. The product itself, its capabilities are changing with every release cycle, so all of your data inputs need to be constantly updated. So those are takeaways for people who are looking to institute data visualization in their own kind of teams. But I guess the higher level takeaway, perhaps for some of you who are experts in data visualization or who want to become interested in that, is that product management teams usually lack dedicated and expert visualization resources. But I would say, and I'm sure my colleagues and my manager would say, that they really shouldn't. So this is really another area that I would say data visualization experts belong in, and this is just another kind of area you can explore.
So I'm just curious, two things. Do you have senior leadership support for what you're doing, or is this sort of a groundswell effort?
I would say it's more of the latter. My boss is actually Nicole. She's come and spoken at Unmil's class a few times. She's really passionate about data visualization and has been for a while. I think our management team maybe doesn't understand some of the complexities behind producing data visualizations. I think they might think it's kind of an easier thing without realizing the kind of inputs that you need on a daily basis. But I think as we've started to produce even very basic things, they're starting to kind of realize it. So we've been able to get funding for things like internships and whatnot. So I think we're definitely getting there. But even an internship isn't going to help us with the ongoing functions that we need, because we brought in an intern last summer to work on one project, but when she left, none of our team members were devoted to it. So the thing that she produced kind of just fell to the wayside.
So, and then just for the panel, it's not always easy to send people away to boot camps for visualization if they exist. Are there any resources that, for a small team they could use to at least get closer to understanding what may work for their audience versus not? Or do you have to take classes for that?
Let me take a stab at that. I haven't come across anything that's comprehensive that will give you some skill set in everything. There are little things that you can do in specific areas. So for example, if you think about, well, how am I going to do some of the theoretical stuff behind visualization? You can you can look at tutorials on YouTube or find web resources on space theory, color theory, Gestalt principles, things like that, to design something better. You can find something in communication that focuses on the communication issue that you brought up, Cynthia, in terms of telling the whole story. But I haven't seen anything that's completely comprehensive and that will give you all of those pieces that are necessary.
So panelists, do you have anything more that you would like to comment on about what Cynthia's talked about?
I had one question. The concerns that you laid out, are those lessons you learned the hard way, or you knew going into it?
No, I don't think we fully anticipated kind of what we were getting into when we started going down this path. Those are things that we've learned along the way from the one project with the release planning. But there have been two other kind of forays that we've made into data visualization where we've encountered these same things repeatedly. So I would say that they're pretty solid takeaways for smaller companies or smaller teams.
And that's a great point, that the process of visualizing data sometimes can spotlight problems with your data or areas where your data could be improved, or so it has another function in addition to just making a pretty picture.
Yeah, exactly. I mean, whenever we started this initiative with trying to track engineering capacity and effort, we found that teams were not recording a lot of the teams that theoretically they should have been. And it also, when you get these data points, it can highlight problems with the team. So I think one of our teams was spending more percentage of their effort on defects and technical debt than they should have been, ideally. So we kind of addressed some underlying fundamental issues with that team and how they're working and why they were producing so much of those kinds of artifacts.
Yeah, in addition to that, actually, you talk a lot about data quality. Mm-hmm. So I think the data quality, especially for some physical related processes, the data quality with the visualization is really very, very good QC tool. So when you put all this data on like one map or in one window, so you can see for certain point or some certain area, it clearly doesn't really make any sense physically. So you can see, okay, there may be some data deficiency there. But on the other hand, actually, the visualization can also be misleading as well. Like, I mean, I'm not sure if you heard about this, the ozone hole discovery, like in the South Pole. So at the beginning, when people trying to visualize this kind of like satellite data, it's actually, they thought it doesn't really make sense physically. So they just forget about this phenomenon like I think for years. And later on, when some of the scientists realized, okay, it's maybe happening, it's really happening. And I think 3 of them won the Nobel Prize because of this discovery.
Thanks, Cynthia. So Beth, you're last. And the Open Government Initiative requires you to make information available to us, citizens. So how have you made that easier by using data visualization?
Sure. So I always, whenever I give a talk, just spend a few minutes explaining what the Comptroller's Office does, because a lot of people don't know. It is a statewide elected office, Comptroller of Public Accounts, and that office serves as the Chief Financial Officer for the state of Texas, which, you know, everything's bigger in Texas, and that can't be more true in the work that we do. We actually manage $90 billion of transactions as the CFO of the state, and our office collects $50 billion a year in revenue across the state. We're also the Chief Procurement Officer for the state and the Revenue Estimator. So the scale and volume of what we do is immense. And we have one area, of course, it makes sense that the Comptroller's Office would be involved, is in fiscal transparency. And that really is an initiative that started, you know, at least 7 or 8 years ago, has really built up over the years. And Texas, I'm proud to say this and have been a part of the team that made this happen, has been a leader in this area. And what this means is showing the taxpayer, where do your dollars go and where do they come from? And we started with, believe it or not, Excel tables posted on the website. This is where this effort began. And the reason why Texas has remained a leader is that we've continually looked at where are the trends, where can we make this better, how can we improve upon what we're doing. So we've had some very intense, rigorous business intelligence tools that we've made available to the public to drill down into very granular detail on state expenditures. We like to say down to the pens and pencils, and that's useful, and it's interesting, and it's important. But we started to sort of get this itch several years back that this information could work harder, and it could work harder if we could provide more context for it. It could work harder if we could aggregate it better. It would work harder if we could visually represent it. So we, on our team, started to make a case, similar to what you were trying to do, to say this is a skill set that we need in-house. This is the value that we believe it will bring, and to advocate for tools to help us do that. And what we learned is the tools alone won't allow you to do that. You really need people in-house who understand the data, who understand the domain, and who understand the story, the question that you're trying to answer, and who understand the aesthetics, which I will always fight for aesthetics, because that does help people understand the information better. It makes it clearer. This is actually a screenshot from some tools we rolled out, I believe, today. These are data visualizations of some drill down tools we've had in the past. If you're curious to know what your government buys and who it buys it from and where your revenue comes from, I encourage you to take a look. This is at texastransparency.org. Just to give you an example, there's a lot of information going on here. If you saw what this would look like in a tabular format, you'd probably run away scared. It would look like Unmil's first slide. But this, for our audience, is, of course, the general public, but we're in a legislative session right now. So for our budget writers to know where has our revenue come from, what has been the percentage change in different categories as they write our budget for the next 2 years, this is critical information to inform their decisions. This is an incredible amount of information boiled down to what I like to call the balsamic reduction. So we really tried to get it to the core information you're trying to get. We have, by bringing these skill sets in-house, been able to leverage it for other projects that we do. We do reports on anything that impacts the Texas economy, so that is really everything. So we've done reports on electricity generation, which you can see there on the left, and on water and drought, and you name it, we've probably done a report on it. We've looked at education costs and the intersection of academic results and costs and how schools are doing, and all of these features we've been able to use data visualization to really, what I like to say is bring the data to life. And the point I wanted to make that Unmil made is it does take a village. And when we at the Comptroller's office said, we really need some data designers, I had to start with, this is probably the best example of structured data, this state's job classification system. And those are very specific job descriptions for very specific duties. And there was not one for a data designer or a data visualization specialist. So we had to try and fit a round peg in a square hole, something like that. And it took quite a bit of effort to massage it and try and decide what kind of skills we needed. That's one of the reasons I reached out to Unmil, because he was teaching a class on this, and to pick his brain and say, what kind of person do we need to be able to do this? And we brought some examples of the work we had done, and Unmil explained to me why pie charts are bad and wrong. And we had a lot of pie charts and the stuff that we were working on. And we did finally come to what I felt like was a good, strong job description that fit within the state classification system, and it was a little bit of this job and a little bit of that job, and we posted it, and nobody qualified. And so we had to take a look at it again, and we really were trying to put everything into one job. Somebody with programming skills and expertise, somebody with information, science expertise, somebody who understands the graphic aesthetics. So it was a process. But I have to say that we did get extremely lucky after we massaged that and really looked at our applicants. And my father always says, luck is when preparation meets opportunity. So we created the opportunity, and we had done our homework to get ready, and we were able to hire 2 phenomenal data designers. They've made a tremendous impact on all the work that we do. As you can see, the 2 examples I showed are just a drop in the bucket on what we've been able to do.
So I'm just curious, as you found these people, it's like the chicken or the egg, I guess. Yes. Are they technical and then they learn your industry? Or, I suppose it just depends on the individual, but do you go for someone who's an industry expert with an interest in doing something more technical? How does that...
I can speak to what our experience has been, and that what we've found is if you bring someone to the table who understands the story of data, the storytelling nature of data, that is where we've really been able to connect the data with the people to create information. So where we found our folks was from the art school, from journalism. The best candidates that we saw were coming from the world of journalism, because there is a need there to create a story from the data. And we have a tremendous technical skill set at the Comptroller's office that can be funneled to effective visualization, but you need someone who can visualize, literally, what that would look like and what you're trying to say with it, more than anything.
And you have a journalism background, right?
I do.
That made you even more aware that that's
Yes.
the kind of storyteller. That's
right.
really a surprising source, I think, for this kind of talent that I wouldn't have thought of. Does anyone on the panel have more to ask of Beth?
Yeah, so we talked a little bit about motivating the decision makers to bring in the talent. And then I can see making a business case in terms of an ROI, whichever eye you pick. You're talking about a bottom line. But it seems to me that in your office, you couldn't have made a bottom line case.
Right.
So what kind of a case did you make for them?
So several different cases. First of all, I'm a big believer in just asking your users. So we actually asked our users, how useful would tools that would visualize this data be to you? And of course, they resoundingly said yes, that would be very useful if you could aggregate it more, if you could make it more consumable for us. So just having your user's voice in that discussion makes a huge difference. The second thing I always do, and this is for any new approach technology you're trying to bring in, is look at your peers, and our peers would be other state agencies, but I would say other government entities, and what they're doing in this arena. And saying, look, we're falling behind. Look at what this state is doing. Look at what the federal government is doing. We're not there yet. And then the third is just what I call sort of the try it and measure. So try it on a small scale and say, wow, this really increased our views, just this small scale visualization of what we're trying to do. We want to take it larger. So that's what I have found. We did this with social media. We did it with everything new that we've tried to introduce. It's just, blaze that trail. Try, measure, compare, and then improve.
Very cool.
So I think we've got some time, probably another 15 minutes or so, to take questions from the audience for the panelists. So anyone with a question? Okay, I'm coming with the mic.
You mean we haven't answered all your questions yet?
I had a question about user validation. So I guess from the Chevron perspective, you work with someone who's doing visualizations outside, and then your own experts can help validate if those visualizations work for your company or not. But in the case of like Texas Comptroller's Office, or Unmil, some of the visualizations that you showed that an agency does, do you have an idea of how they get end user validation, or how y'all might get end user validation, the actual people using the product?
User validation in what way? That it's useful
Yeah.
and that it's helpful?
Yep.
Honestly, I just ask them. On all of our websites that we make available, we always have a survey, and like on some of the new visualization tools that we rolled out, we created a survey specific to that tool to ask them if that was helpful, what wasn't on there that they would like to see, is there another way they'd like to see the data? And it's something you do all the time and you never end. And that's what I love about the work that we do, is it constantly can evolve and get better and also be responsive. But to look at everybody's input, it's easy to be reactive to just one person's comments, but to look over the long term and say, what are people really saying about the usefulness of this information and how we're presenting it?
Yeah, I would say at Tasktop at my company, so the release plan example, it's kind of a strange thing because we are the ones who are consuming that information. Our team was producing that for our own team's planning purposes. So, we kind of have a good sense of whether or not it's giving us what we need. And right now it is, again, except that the manual collection of it is getting more unsustainable. And we're sure that there are more robust ways we could, visualize that to get even deeper insights. But I guess I'll shift to another example that I quickly touched on, but couldn't really go into too much detail on, which is field enablement. So again, this is just the process by which our team shares information about the product's capabilities with our field. So in this case, our solutions guys, our sales guys, our customers. And we could get a very good sense of whether or not the information and how we're giving it to them is useful if they're actually consuming it. Because those guys are out, they're really busy, and they need something that's very easily consumable. And if they can't get that, they're not going to even bother with the information. They're just going to come directly to us. So we, right now, get a ton of one-off emails asking about this feature or that feature whenever we have an internal wiki that documents all of this. But the thing is, right now, it's documented in a textual way. It's not easy to find. So we often find that the content we are producing is left, and no one's really discovering it. Whereas if we did have the resource to go and produce something, that could include the level of detail that we need it to, but in a way that was easily consumable, that would be a much more useful tool for them.
Well, so this is where you go back into that full circle mode, where you're doing visualization, and the way you find out whether it's useful or not is you do more data mining and data analysis and get more data to find the answer. One way that Beth mentioned is to do surveys. But then you can also do things like, especially for websites, you can do weblog analysis, use Google Analytics, or perhaps some other tool. Like now you're seeing more and more the ELK stack becoming more popular for web log analysis. You can do instrumentation of your software code and see which pages get the most visits, or internally, even if you're using custom software, you can instrument the software and see what gets used, what doesn't get used. So yeah, both automatic data gathering and human data gathering.
Any other questions?
I wrote mine down. It's kind of long. It might be a multi-part question. So my question was for Fuyu. I was kind of interested, you talked about from a user experience, and I feel like everyone else on the panel has pretty what I would call nice data. It's a spreadsheet, it's in a format, but I wonder about like what are the challenges you face in regards to hardware and software when you're out in the field, when you're taking geological data and you're on a boat and there are waves and there's like how do you get the accuracy of the data, and I'm assuming there's lots of equipment that happens. It's not instantly into a spreadsheet. There could be multiple points of error in that data collection, and sort of if you could talk a little bit about how you do that analysis in the field, real time, and the challenges that are specific to that.
Okay, a disclaimer is I have never been to the field, but then, but I know. I mean, there are some. Actually, my wife is a geophysicist in Chevron, so she's working on the data acquisition part. You get the seismic data. It's not really a challenging to the software or maybe the hardware. So you know, I mean, there's certain uncertainties. There's certain errors built into that data, and you have some techniques to. I mean, maybe to take away the noise, and just you need to have the information about how you get the data, and then you know where I mean how you can massage the data to really make some sense out of the data. Yeah. So it's not really a hardware issue or software issue. I mean, there are tons of errors in any data.
Yes, I appreciate that you think our data's nice and clean and in spreadsheets, but it is a challenge all the time. Like I said earlier, it all begins and ends with the quality of the data. And if you ever want to scramble your brain a little bit, you can sit down with some of our fiscal management folks and talk about state budgeting expenditures and revenues and categories, and it's very, very complicated.
Yeah, I used to work for Chevron Information Technology when it went from computer service department to Chevron IT, and I was involved in billing for resources for IT, and one of the things was the tapes that had the seismic data, and I'm just wondering if it's still on tape or not.
Linda, yeah.
Oh, wow.
Well, is this gonna wait? Put it somewhere else. Yeah. Right. I mean, do you still have the tape drives?
No, we don't. We have to send it out to have the tapes treated.
Oh, okay. Well, my other background is in clinical trials. I've been working in clinical trials as a SAS programmer here in Austin after I left Chevron when they downsized. And so when I've run into all the issues that Cynthia talked about when I worked in Chevron IT for 20 years. And there was an organization of about 2,000 people. So anyway, that's all I had.
Did we have another?
Well, I had a question.
Okay.
The question is primarily for Fuyu Li. On your visualizations, do you have a lot of, when is it appropriate to use text to describe your data visualizations? I mean, is text dead?
No, but
I mean, like, how do you describe, let's say for the public, how would you describe, your complex data visualizations? And also, isn't there an issue of, all these pretty pictures, but oversimplification of a complex issue? I mean,
actually, I chose, prettier pictures for this presentation. But normally, in the real work, we try to make simpler pictures. So, like for my one example is like for my PhD work. Like what my supervisor told me is, if you can summarize your PhD work into 3 figures, that would be good. So we try to make the pictures as simple as possible, so that you can you summarize your results and highlight some of the innovation like in your work, and especially like when you show to the decision makers, you have to make the figures of the visuals as simple as possible. Yeah,
But, I mean, do you have like a report report that describes those? You know, I mean, do you have text that describes those for like the public to understand?
Yeah, there are always texts, but
Okay.
yeah. But what the point I want to make here is visualization is a necessary part. Is to can facilitate all this kind of communication, and can make a better case. But the text is always there.
Okay.
Yeah.
Any other questions?
I just wanted to add a little bit to what Fuyu has described as far as Chevron doing exploration. A lot of times we do build these models early on, but as we start drilling, we have real-time drill feeds that come back to headquarters, say. So it's a constant battle of a barrage of data that's coming in from the drilling rig. And it's all kinds of measurements. It's electromagnetic, it's everything. And as that data comes in, that model is changed on the fly. So as we encounter new rock types, we know where the barriers are between the layers of the earth. So we get a lot of data, I mean, petabytes of data coming in real time. And these models are adjusted also in real time as this data comes in. So we learn as we drill and we update our models. So that gives us a much better idea of, you know, hitting the right spots, hitting the bright spots, and finding the hydrocarbons underground. So.
How many people do you have working on this?
We have modeling staffs. We have interpreters that are trying to figure out where these layers of Earth, you know, intersect, because this is where the hydrocarbons will be found. Oh, this is working. And we've got modelers. We've got, we have departments of people that do each of these functions. So it's quite and these are highly paid people that PhDs, and so it's a very technical area, as you can see. And Fuyu's one of our newer employees that's going to be, you know, has a bright future with our company.
Any other questions? Okay, then panelists, just any final words as we make our way to high noon and lunch?
I hate to stand between anybody and lunch.
Well, I hate to pass up an opportunity to speak. So one of the things that I read recently was that big data has always been around. We've always had more data than we can process. The only thing that's new in today's age, that our ability to process data has increased dramatically, and so we can start thinking of new solutions to the challenges of big data. So it's not necessarily a challenge of big data that we are facing right now, it's a challenge of big processing. How do we go about finding the solutions using data that, yes, we have better sensors, so we are getting more data, but really the interesting part is that we now have more storage space and more processing capability. So focusing our attention more on finding interesting problems and finding interesting solutions for them is where the key is, rather than focusing on the data that we have. And the other thing, since Beth brought up pie charts, yes, pie charts are evil. Avoid pie charts whenever you can. And then the problem here is in terms of theory, right? You're using two-dimensional space to model one-dimensional information. The human brain is terrible at doing that. If you want to learn more theoretical stuff, come to my visualization class.
I think we need to tweet that pie charts are evil. Yeah. Any other closing thoughts?
Yeah, one point I want to make is visualization is very, very important, but it can be interesting as well. It's not really that boring. No. Yeah. Yeah, I know. Actually, I know a scientist who has the art background. So he used some of the satellite images, some pure boring data, and really make some really, really fun artwork. Yeah. So.
Really nice. That's a great way to end the session. Thank you, panelists. It was fantastic, the work you put into showing us some wonderful, fascinating things and lessons learned. It's been really valuable. I appreciate it.
Thank you.